Good morning, everybody, and welcome to the Great Agri-Food Debate 2024 for students of agriculture and food at third level institutions across Ireland and the UK for what is our 9th Great Agri-Food Debate. My name is Paul Nolan. I'm Group Development Manager with Dawn Meats, and I'm your moderator this morning. So once again, welcome to everybody, including, of course, our two participating teams this morning. Scotland's Rural College, or SRUC, captained by Nicola Gould, and SETU, Southeastern Technological University from Waterford, captained by Ellen Doherty. The motion today is intensive global animal protein production is to blame for antimicrobial resistance. Proposing the motion is the team from SRUC, and opposing is, of course, the team from SETU. It should be noted that the stance taken by the teams are the positions that have been assigned to them by random draw and do not necessarily, of course, reflect their point of view. We'd be delighted if people would get involved through Twitter, and the handle is #GreatAgriFoodDebate. You will notice that your microphone has been muted automatically, so we ask you to kindly keep it muted unless, of course, you are speaking. We can't have a debate without judges, of course, and I'm delighted to welcome our three judges this morning, Brian, Ronan and Nicholas. And I'll ask each of the judges now perhaps just to introduce themselves. So Brian, if we could start with you, please.
Hi, I'm Brian Hyland. I'm the Food Safety, Quality and Animal Welfare Director for the Dawn Meats Group, and very much looking forward to today's very important topic being debated.
Thanks a million, Brian.
Hi, Paul. Ronan Clinton, partner with EY, based in our Waterford office. Like Brian, I've been a judge for, I think this is my third or fourth debate. So really looking forward to hearing both sides of the argument, and best of luck to both teams. Thanks, Paul.
Thank you very much indeed. And Nicholas?
Nicholas Safar, I'm Chairman of the Agricultural Horticultural Development Board. Like the others, this is not my first judging event, so good luck to both teams, and it is a very important debate.
Thank you very much, Nicholas, and we look forward to the input from the judges a little later on. So before we get down to business, I suppose it's important to do two things. Firstly, I want to thank Dawn Meats and McDonald's, who are proud to be supporting the next generation of business leaders through initiatives like the Great Agri-Food Debate. And the second thing I'd like to do is just to very briefly reintroduce the rules, not going into any great detail, but just to remember that you have already received the details in your handouts. But some of the key points to notice are that the team captains will open and close the debate and introduce their teammates. Each student's speech will be a maximum of 5 minutes. And my colleague Eileen, our timekeeper, is with us today. And Eileen will give you a hint at 4 minutes and an instruction close after 5. Time will be, as I said, monitored by Eileen. And remember that interrupting a student while they are speaking is not allowed. After each speaker, 1 point of information may be offered by the competing team. And please remember to keep it precise and to the point. At the end of the day, it is precisely that, a point of information. And finally, points of information are not allowed following the captain's closing arguments. And so we get to the first debate of our 2024 series. And as I said, we are delighted to have our team from SRU proposing the motion and our team from SETU to oppose. And to remind you once again, ladies and gentlemen, that the motion is intensive global animal protein production is to blame for antimicrobial resistance. So without further ado, I would like to ask the captain for SRUC to open the debate. Nicola, over to you.
Good morning, judges, opponents, and the audience. I'm Nicola, and we are proposing that intensive global animal protein production is to blame for antimicrobial resistance. Today, we face a global health crisis that affects us all, antimicrobial resistance, known as AMR. Imagine a world where the most basic infection becomes lethal, where routine surgery carries the risk of untreatable infection, and where medicines we take for granted no longer work. By 2050, that world could become a reality. AMR is projected to kill 10 million people annually and over 200,000 newborn deaths per year, a toll greater than cancer. And we must ask why. What is fueling this crisis? Well, the answer is our food systems, intensive global animal protein production. As the global demand for animal meat rises due to population increase, so does the reliance on intensive farming, a system that maximizes output but carries a lethal hidden cost. In these high-intensity environments, animals are crowded, stressed, which has implications on the immune system, which allows a high susceptibility to disease amongst other factors like poor environmental management and welfare standards at its lowest. To keep this system running, a reliance on antimicrobials has been achieved. At such a level, it defies common sense, not just to treat disease, but to prevent it, promote growth, and other factors like poor environmental management and welfare standards at its lowest. However, there is a cost, and it's one that we're all now paying. This is the fundamental problem. Antimicrobials create selective pressure. When we expose bacteria to antibiotics routinely, we're not eradicating them, we're arming them. We are allowing the strongest, most resistant bacteria to survive, thrive, and then morph into superbugs. These superbugs don't just stay on the farm within the animals. No. They move through the food chain, through water, soil, and our environment, and even into our human bodies. The result? A growing list of bacterial, viral, and fungal infections that we cannot treat effectively. An overview by the World Health Organization concluded that drug resistance is now found in conditions like tuberculosis, Staphylococcus aureus, Escherichia coli, HIV, influenza, and a new emerging strain, Candida auris, which is resistant to antifungal medications. Now, this is a complicated issue, as I'm sure you will all be aware. Growing concerns with climate temperatures could impact the surge of AMR. Natural compounds from plants and arable farming and the environment and systems. However, our position is clear. Intensive animal protein production is a cataclysmic driver of AMR. And this is not just a scientific theory. It is happening today. Today, we will show you how and why this system is not only risking lives, but impacting global economy. Our first speaker, Rowan, will illustrate the rise of AMR in intensive farming. Not only that, they will shine light on how developing countries still contribute to this escalating problem. They will show you that this isn't just bad practice. It is a breeding ground for resistance. Our second speaker, Kira, will highlight the dire consequences of AMR. They will explain how the rise of untreatable infections threatens public health, drains economy, and contaminates the environment. And finally, our third speaker, Nagori, will address the ethics of this subject, the subject of strategy and solutions. They will prove that alternatives to intensive farming exist, alternatives that ensure food security without sacrificing public and animal health. They will counter the claim that human misuse is solely to blame, proving that intensive farming is a preventable and powerful contributor to AMR. So we ask you all, is it worth compromising the effectiveness of our life-saving medicines for short-term productivity gains? Intensive animal farming is fueling antimicrobial resistance at a dangerous and unprecedented pace. Thank you.
Thank you very much, Nicola. Well done. And now we'll hand over to the opposition captain from SETU, Ellen Doherty, to oppose the motion. Intensive global animal protein production is to blame for antimicrobial resistance. Ellen.
Okay. Good morning, chairperson, adjudicators, and members of the proposition. My name is Ellen Doherty. I'm a proud dairy and beef farmer from County Kilkenny and captain of the SETU debating team. I would like to welcome you all here today. I'm here with my fellow teammates, Brittany, Edward, and Alicia, to strongly oppose the motion that intensive global animal protein production is to blame for antimicrobial resistance. Firstly, to define the key terms of this motion. Intensive can be defined as something involving great effort or energy. Global means worldwide. Animal protein production is the process of making a protein which is of high quality and contains adequate and balanced amounts of amino acids. Or, more simply, the farming of livestock, including dairy and beef cattle, sheep, pigs, and poultry. To blame, a word which us farmers seem to encounter time and time again, can be defined as assigning the sole responsibility for a bad situation to someone. Antimicrobial resistance, AMR, is defined as a natural process that occurs over time through genetic changes in pathogens, and its emergence and spread is accelerated by human activity, mainly through the misuse and overuse of antimicrobials in humans, animals, and plants. So, to redefine the motion today, we would say worldwide livestock farming is undoubtedly not solely responsible for antimicrobial resistance. We do acknowledge that intensive farming systems have contributed to AMR. However, for the proposition to place the blame solely on our sector is being disingenuous. The reality is that the issue lies closer to home, with the misuse and overuse of antibiotics in humans and poor human hygiene, in fact, being the main driver of AMR. AMR is a global problem, yes. However, the causes of AMR are much more complex than what the proposition would have you believe. All of the members of the SETU team are farmers. What's more, we are all science students. We have carefully examined all the scientific facts and published research on this debate topic, and we are confident that this motion will be defeated. The World Health Organization set up the One Health approach back in 2015. One Health is the concept that recognizes that the health of people is connected to the health of animals and the environment. Brittany, our first speaker, will outline who the first culprit is, exploring the fact that overprescription and misuse of antibiotics in human health is the leading cause of AMR. She will also discuss how our poor standards of human hygiene are also aiding the spread of AMR. Edward will then explain that AMR is observed as a One Health approach, both as a cause and a solution, encompassing the interactions between humans, animals, and the environment. He will also look at studies that place the blame for AMR on factors other than intensive global animal protein production. Alicia will follow up by posing this question. How can intensive animal protein production be blamed now for AMR, given the reality of how the livestock farming sector globally have responded in recent years, and how scrutinised and controlled antimicrobials are in the agricultural sector? For many years now, the livestock sector has engaged in a broad range of practices that have in fact curbed the spread of antimicrobial resistance. Ladies and gentlemen, I urge you all to defeat the motion here today. Thank you.
Thank you very much for that, Ellen. So we've now heard from both captains in their opening remarks and indeed setting the tone for this debate. So next up, I'd like to call on behalf of the opposing team, SETU, Brittany, please.
Chairperson, adjudicators, members of the proposition. My name is Brittany, and I'm a third-year agricultural student here at SETU. I am here today to formally oppose the motion that intensive global animal protein production is to blame for antimicrobial resistance. But first, let's talk about antimicrobials to get a better picture of why there is a problem to begin with. Antimicrobials are medicines such as antibiotics used to prevent and treat infections. These medicines are very useful drugs and save many lives as well as help people have a better quality of life. When an antimicrobial medicine that previously worked to treat an infection or disease caused by a microorganism stops working or does not work as well as it did before, this is called antimicrobial resistance, also known as AMR. Let's not forget how bacteria themselves can resist even the strongest antibiotics. Bacteria have developed various and ingenious strategies to withstand the antibacterial effects of previously effective medications in treating illnesses. Effectively, bacteria themselves can make structural modifications that often decreases the effectiveness of antibiotics, leading to AMR. It should be noted that although AMR does happen naturally over time, it is made worse, however, by overusing antimicrobial medicines and by not using them correctly. So, tell me then, why are you pointing the finger at animal protein production as if they are the problem child? The World Health Organization does not blame global intensive animal protein production for AMR. They specifically state that the main contributing factor regarding AMR is the misuse and overuse of antibiotics in humans. They also point the finger at the lack of access to clean water, sanitation, and poor hygiene. Let's be honest here, a lot of people don't wash their hands for long enough, and sometimes not even at all. The World Health Organization also blamed inadequate infection and disease prevention, poor access to quality and affordable vaccines, diagnostics, and medicines as other causes of AMR. It's not just the World Health Organization saying this. According to an article published in the Journal of Medicine, Surgery, and Public Health in April this year, natural selection, antibiotic overuse and misuse, insufficient access to safe water and sanitation are the main causes of AMR. No mention of global animal protein production here either. Antibiotic overuse and misuse includes, but is not limited to, incomplete treatment, inappropriate prescription, and self-medication. With this in mind, if we were to be honest with ourselves, then answer this question. How many of us here today have been prescribed antibiotics for what turned out to be a viral infection, or not finished a course of antibiotics, or even self-medicated with someone else's unfinished drugs? If you have answered yes to this question, then perhaps you are part of the problem. Keep in mind that human travel can act as a vessel to further this problem, as different strains of diseases are transported to different regions all over the world. The Federal Aviation Administration put out an article in May of 2024 stating that 2.9 million passengers fly in and out of the United States airports every day, and that is only in the United States. And let's be honest, cattle aren't heading off on their hollybobs to Spain, now are they? Something to think about. Antimicrobial resistance is a global problem and is a massive threat to us all. However, more accomplished and world-renowned scientists and policymakers than our own team here today also agree that many factors, many sectors, and many policies are to blame for this issue. And just maybe we should stop handing antibiotics out like they're candy. Just saying. Thank you for your time.
Thank you very much indeed, Brittany. Just wondering, at this point, have SRUC any points of information they wish to take up with Brittany?
Yes, we do. Brittany states that mostly it's the misuse of antibiotics in humans, but the recent research was 80% of all antibiotics sold within the United States of America was actually given to agriculture for livestock protein production.
Time.
Thank you. Brittany? Do you wish to respond, Brittany?
Yes. There is
Go
an
ahead.
EU-wide ban on the use of antimicrobials as growth promoters. There's a huge restriction on their in other countries as well. In the US alone, there is a ban across all livestock except for limited use of antimicrobials in poultry. The World Organization for Animal Health is demanding an all-out ban everywhere and except to be enforced. Once again, the livestock sector is already doing its bit to reduce AMR. We can say that the amount of others, can we say that the other sectors are doing the same?
So thanks to Brittany from SETU opposing the motion. And we now welcome Rowan McKay from SRUC, who of course is on the team proposing the motion, intensive global animal protein production is to blame for antimicrobial resistance. Over to you, Rowan.
Thank you. So today we propose that intensive farming is to blame for antimicrobial resistance. And as the opposition rightly said, AMR occurs where bacteria, viruses, fungi and parasites don't respond to the medicines designed to treat infections, which then renders medicines ineffective. According to the World Health Organization, however, that is a natural process, but human activities, particularly the misuse of antimicrobials in farming, have accelerated its emergence. The overuse of antimicrobials in agriculture has long been a contributor to the emergence of AMR. Initially, things like antibiotics were used to treat sick animals, but over time, they began to be used preventatively or as a growth promoter. A growth promoter is a substance added to animal feed which can increase livestock by as much as 8% in growth, just by boosting the efficiency with which the animals process food. Farmers use antibiotics to prevent disease and promote growth, especially in crowded conditions, creating an environment where bacteria are exposed to constant low-level doses of antimicrobial agents, such as through pesticide exposure and imported feed to the UK. As highlighted by the CDC, growth promoters are not fully digestible by animals. The undigested remnants are excreted in the animal's feces, contaminating the soil and allowing resistant bacteria to spread through the soil, water and crops, which indirectly transmits AMR to humans. Even in countries where the use of antibiotics has been restricted, such as here in the UK, the problem persists. The UK imports roughly 10% of its beef just from Brazil, a country where the use of antibiotics as growth promoters is 17.5% higher than any other developing country. The UK also imports significant amounts of meat from China, another country where antimicrobial resistance is rife and the regulations are less stringent. This means that even though the UK banned growth-promoting antibiotics in 2006, the imported meat still carries resistant bacteria, and we still use it as a preventative today. In fact, the global flow of food is a key vector in spreading AMR. As the UK imports about 250,000 tonnes of meat annually, it's importing not just food, but the potential to spread AMR. This is a direct threat to human health, as these resistant bacteria can bypass the regulatory measures set in place to halt the progress of AMR here in the UK. The preventative use of antibiotics in farming is another major contributor to AMR. According to the Food and Drug Administration of the United States, in 2014, 80% of antibiotics in the United States were for non-human use. And of that, 62% were given to farm animals for things other than treating an illness. These antibiotics are often broad spectrum, meaning they target a wide range of bacteria, and their continuous use disrupts the animal's natural gut microbiota, creating a perfect environment for resistant bacteria to flourish. This damage is irreversible, as research shows that long-term exposure to antibiotics, especially since growth promoters don't fully absorb, significantly alter the GI microbiota of farm animals. What is the result of this? Microbes that were once susceptible to antimicrobials become completely resistant. And these resistant pathogens do not stay confined to the animals, they spread to us, through the consumption of contaminated meat or direct contact with farm environments. Even if antibiotics are not digested by the animal, it still has the potential to contribute to AMR, allowing natural microbiomes to develop resistance to drugs without ever encountering the microbe, which causes immunity to the drug, but not to the illness. While antibiotics were once a life-saving tool in human and vet medicine, their overuse as growth promoters in farming has accelerated the rise of AMR and putting our own health at risk as a result. Thank you.
So thank you very much, Rowan, for that robust positioning. Any point of information from SETU for Rowan, please?
The key is the motion to this debate. The motion says globally, you've focused on small populations. The EU say banned the use of growth inhibitors in 2005. Many countries are following this forward.
Rowan?
Yes, so the EU did in 2016 ban growth promoter use. However, you can still use it as a preventative, and we still do that in the UK, quite widespread, and we do it in Ireland as well. I think limiting ourselves just to the EU and to the United States would be a mistake, because although there's a ban, it's not complete.
Thank you very much. So can I now call on Edward Hatton from SETU opposing the motion, please? Edward, over to you.
Chairperson, adjudicators, members of the proposition. My name is Edward Hatton, and I'm a proud beef and tillage farmer from County Carlow. I've been listening carefully to the proposition team, and I'm astounded at the misinformation and fake news here today, such as Ronan's statement about using antibiotics preventively here in Ireland. I mean, is this a US presidential debate? Let's all please look again at today's motion. The motion is very clear. It places the blame for AMR on global animal protein production. We will show from the research that this is not the case. The World Health Organization set up the One Health approach back in 2015. One Health is the concept that recognizes the health of people is connected to the health of animals and our environment. Brittany has already told us how human behavior, in particular to antibiotic misuse, is the main driver for AMR. In fact, only recently, the UN Food and Agricultural Organization stated, and I quote, "There remains little doubt, however, that the most significant factor in AMR emergence is antimicrobial usage for human treatment and prevention." We as farmers are always in the spotlight. We are constantly making changes and striving to produce better quality products for human consumption. Despite what Ronan has told you in relation to antibiotic usage by the livestock sector, of the 25 countries providing sales data in the European surveillance of veterinary antimicrobial consumption, there was a decrease of 53% in sales of antibiotics for food-producing animals. We have achieved this through many measures, such as greater biosecurity and animal hygiene. Can we say we, as humans, have done the same with human antibiotic usage? Recent scientific studies claim that most of the emergence of AMR in bacteria in humans appears to originate from human use of antibiotics, whereas the majority of AMR in bacteria and livestock seem to originate from antimicrobial use in the livestock. We only have to look at the proposition's home country for proof. Well, Nicola, a study conducted in your home country, Scotland, showed that phylogenetic and whole genome sequence analysis of Salmonella in human and livestock populations has shown a greater diversity of AMR genes in humans by comparison with those in livestock populations. The implication is that there were sources other than animal proteins that was contributing to AMR in humans. A 2008 article by Martinez observed that antibiotic-resistant bacteria are common even in environments that do not have a high antibiotic use. It is simply a natural characteristic. It's been reported that a lack of biodiversity in ecosystems, often due to human action, also seem to drive the emergence of resistant bacteria. Between sowing multi-species swards, preserving native breeds, setting aside protected habitats, and generally managing our beautiful countryside, no one works harder than us farmers to promote and protect that biodiversity, as well as to put meat and milk on the table. The idea proposed by Nicola that intensive livestock production is responsible is simplistic. A study across Ireland, the UK, and the Netherlands reported that 70% of antibiotics used by humans are excreted in active forms, and shockingly, are not eliminated in wastewater treatment. Even worse, those researchers found this AMR bacteria derived from human fecal sources at popular beach locations. Think about this the next time you go swimming. With legislation, best practice, and quality assurance schemes all there to prevent AMR in our food chain, where is the protection of our waters? Unlike the proposition, we're living in the real world here.
Time.
We need animal protein production to feed a growing population with an acceptable quality of feed, as well as to keep our rural communities alive. As for today's motion, the blame for AMR is much more complex than just placing it on intensive global animal protein production, but actually a number of factors which many are scared to admit. Thank you.
Thank you very much, Edward from SETU. So I would ask if there is a point of information on behalf of SRUC, please.
You said before that humans only have put in antibiotics in the environment because they're not digested properly, but also the CDC found that animals also a large number of antibiotics in their systems are also not digested properly and also go into the environment. So it's not just humans are to blame.
Time.
Thank you. Edward, would you like to respond, please, if you heard that?
Yeah. Well, considering you got to hear Ellen's speech twice, you would have heard that she said that we're not solely to blame. Animal production is not solely to blame for it. We have admitted that in the past it has, but now, we're seeing this AMR bacteria coming from humans in popular beach locations. And also there's so much more testing and paperwork for the farmers compared to human use of antibiotics. So the traceability is a lot more present for animals.
Thank you very much, Edward. So to propose the motion, intensive global animal protein production is to blame for antimicrobial resistance. It is my pleasure now to call on Ciara Young from SRUC. Ciara.
Good morning and thank you. Antimicrobial resistance already has severe repercussions on animal and human health, the environment, and our economy. All of these outcomes are predicted to worsen as time goes on if this lack of action continues. In Europe, there are over 700,000 instances of infection which have developed a resistance to antibiotic treatment, with 33,000 of these cases resulting in a mortality annually. Not only is there an immense loss of life which would otherwise have been preventable, the cases which should not result in a death still hugely use up our public health resources. With increased AMR comes decreased effectiveness of standard treatments, leading to a greater reliance on alternative therapies. These are more costly and usually have a longer treatment plan, resulting in a lengthier recovery period. The costs associated with these difficult to treat infections amount to over €1.5 billion annually. With this increased duration of illness comes lengthier terms of sick leave, as well as a requirement for further resources provided by our healthcare system, which, as you can imagine, draws more money for a multitude of reasons. While it can be argued that this is still somewhat manageable in its current stage, if the occurrence of AMR continues at this rate, essential routine therapies such as investigative surgery and neonatal care will become exponentially more dangerous as we continue to lack the means to control infection or the risk thereof. This impact on human health, of course, can be attributed to the overprescribing of antibiotic courses to humans, but also to the consumption of animal protein that's produced from these intensive systems. While there are these indirect blows to the working of our economy, from infections which would otherwise be a simple fix, increased AMR in our livestock is also attacking our farmers. Increases in untreatable or difficult to treat infection in our livestock results in a greater loss of life, decreased profitability, as well as an overall reduction in welfare. It is estimated by 2050 that these specific losses promoted by resistant infections could amount to a £3 billion loss annually. With the decrease in profit, we will see a rise in the price of meat during a time where food costs are already out of control, payable, of course, by the consumer. Or meat will simply be imported at an even higher rate to satisfy the public from countries which do not have such progression in the reduction of antimicrobial use. But this then continues the cycle and continues to leach resistant pathogens into our food chain and furthermore into our environment. These resistant pathogens are primarily released into the environment through fecal waste of livestock, which is further utilised as fertiliser, impacting the soil and eventually the waterways. Additionally, improper disposal of antimicrobials allows another point of entry into our environment, promoting adaptations and developed resistances in pathogens already found there. Contact with affected soil and water, as well as the consumption of food from these affected areas, increases transmission and once again amplifies the problem. Not only this, but it exposes our wildlife to these threats too, wherein they become further vectors for transmission. More and more avenues for transmission become apparent, making the subsequent threat of AMR inevitable if suitable action is not taken. Thank you.
Okay. So thank you, Ciara, for your very robust defence. I'd now like to invite SETU if they have a point of information, please.
Ciara, if global animal protein production is to blame for AMR, then what alternative would you suggest for animal protein given the rise in population and our need for food security?
Back to you, Ciara.
Thank you. So it's again going back to this point of a global reduction in the use of antibiotics, so both as growth promoters and as a treatment. Of course, we've made good progress in the UK and Europe in general, but it's a global issue. It needs to be tackled everywhere.
Thank you very much, Ciara. My, how time flies. We are already at the fourth and last speakers before the concluding remarks from the captains. So at this point, it is my pleasure to introduce Alicia Flynn from SETU, opposing the motion, intensive global animal protein production is to blame for antimicrobial resistance. Over to you, Alicia.
Good morning, Chairperson, adjudicators and members of the proposition. My name is Alicia Flynn and I am a proud dairy and beef farmer from County Waterford. I take great pride in standing here to defend the agricultural community, a community that works tirelessly to provide a safe and healthy food. First, let me share my own experience. On my farm, as on many others, we are committed to minimising antibiotic use. We employ methods like selective dry cow therapy, treating only cows that need antibiotic usage. When a cow does require antibiotics, such as in the case of mastitis, strict protocols are followed to ensure her milk does not enter the bulk tank as well as the supply chain. Instead, it is disposed of appropriately, and major suppliers like Tier Lawn, Dairy Gold and many others have rigorous testing systems to detect any antibiotic residues. And farmers are penalised if they do not comply. This is a shared responsibility we take very seriously. I take great insult in hearing statements from Rowan suggesting that farmers are deliberately overusing antibiotics. While antibiotic usage was once higher, we have seen considerable reductions in recent years. Sales of antibiotics in animal agriculture have declined, demonstrating our commitment to responsible usage. So I ask you, has human antibiotic usage decreased or increased? It has increased. Now let's talk about the future. With an expected global population increase of 1 billion people by 2030, we face a significant challenge. More people mean more mouths to feed, demanding increased food production. This is not just about farming, it's about feeding the world, a responsibility farmers take very seriously. The proposition will no doubt suggest that reducing animal protein is the answer. Let's be quite clear here. Our bodies rely on essential nutrients that are more readily available in animal protein than plant protein, such as creatine, an irreplaceable nutrient that is vital for muscle function and overall health. Reducing this could lead to health issues, necessitating even more antibiotic usage. It's essential to understand that antimicrobial resistance is a complex issue. The World Health Organization has identified 3 major areas involved in addressing this issue: human health, animal health, and environmental health. Listen, Nicola and your team. The problem doesn't lie solely with the farmers. It's a global challenge that requires a One Health strategy, recognizing the interconnectedness of all these elements. When we discuss suppliers, it's worth noting that this commitment to responsible antibiotic usage is shared by milk suppliers across regions. Suppliers like Scotland's Scott Milk and First Milk, alongside Tyrlawn, Dairy Gold, Fonterra, and many others, have strict standards to ensure safe, high-quality milk free from antibiotics. This is not an issue confined to one country. It's a shared responsibility across the farming community and in Ireland, Scotland, the EU, and globally. Seeing as Kier couldn't answer the question that she was asked, I was assuming that you were going to suggest the rise of lab-made proteins. These synthetic alternatives may appear to be a solution, but they come with their own concerns. Lab-made proteins risk replacing our traditional agricultural practices and undermining the essence of our rural way of life. Can a lab replicate the natural benefits of animal protein? The reality is that food production doesn't end on the farm. Every piece of meat undergoes multiple stages of processing, packaging, and distribution, each carrying its own potential risks. Are we prepared to let labs take over these responsibilities with unknown impacts on nutrition and the economy? We, the farmers, are custodians of the land. We are deeply invested in sustainable practices, and we grow weary of being blamed for issues like climate change, animal welfare concerns, and antimicrobial resistance. Farming is an integral part of our society, and rather than pointing fingers, we should be collaborating to find solutions. In conclusion, while antimicrobial resistance is a real-life and significant issue, it is not fair to lay the blame solely at the feet of animal protein production. Let's work together, farmers, scientists, and consumers, to ensure a healthy future for all. Thank you.
Thank you very much, Alicia. And I wonder if there's a point of information required from SRUC, please. Yes, please. Yeah, I see the hand up. So somebody's going to make the point, please.
You suggested that our stance was to reduce protein production, but there are other strategies to maintain productivity, other than just reducing the entire product created. We're just not antibiotics or antimicrobials.
Over to you, Alicia.
Well, what I want to say back here is that, like, you're saying that, like, so farmers are trying their best everywhere and they're following their regulations. So you're saying that there's other alternatives, but you actually haven't suggested any alternative. So.
Thank you very much for that, Alicia, for your response. It is now my pleasure to introduce the last speaker from SRUC, proposing the motion, intensive global animal protein production is to blame for antimicrobial resistance. Nagora Kurtango, it's over to you, and thank you.
Thank you. I would just like to start my argument by asking the opposition to stop focusing on personal farms. This is a global issue. I understand a lot of these practices are banned in the EU, but we have to work together to stop this issue. This is not a blame game. I am not blaming you personally for these issues. We must work together to find a solution. As you know, antimicrobial resistance is a pressing global issue. In 2019, over 1 million deaths per year were attributable to resistant bacterial infections, and over 200,000 of which were newborn deaths from resistant bacterial sepsis alone. However, these numbers are often not included in global estimates. Much of this burden is seen in low and middle income countries, where there is more reliance on antibiotics as growth promoters, and research and funding for alternatives is scarce. AMR is predicted to cause more than 10 million deaths annually by 2050. This loss of first-line microbials has grown reliance on other therapies, which are often more expensive, harmful, and require longer treatment durations. And the biggest issue is that there's insufficient research into new medications, meaning that resistance is developing faster than new medications are being created. While it is illegal in the UK and EU to give antibiotics as growth promoters, it is still legal to give them routinely to compensate for preventable husbandry issues such as poor hygiene. It is also still legal to import products produced with antibiotic growth promoters from other countries, as my colleagues have mentioned. This excessive use of antimicrobials has caused high cases of resistance to strep, E. coli, and salmonella in animals. And tuberculosis, HIV, and influenza medication for humans is becoming less and less functional. This burden is seen especially in low and middle income countries where they do not have the access to complex combination treatments. And we cannot ignore the issue of food security. However, here in the UK and in Ireland, we have more than enough resources to find alternatives where other countries may not have a choice. So on to solutions. Following the creation of AMR policies in the Netherlands, they found a 43% reduction of AMR symptoms in slaughter pigs. In only 5 years, they were able to reduce their use of antimicrobials by 60%, with the goal of eradicating their use entirely, and found a reduction of these symptoms in all commonly farmed animals. The One Health approach is a unifying approach to optimize the health of people, animals, and the environment. It's particularly important to prevent and respond to global health threats such as zoonosis, pollution, and especially antimicrobial resistance. This approach addresses root causes and creates long-term sustainable solutions at a local, national, and global level. This concept is very closely tied to antibiotic stewardship. This is a systematic approach to educate and support healthcare professionals on guidelines for prescribing and administering antimicrobials. The World Health Organization funds antimicrobial stewardship programs, which is one of the most cost-effective interventions to optimize the use of antimicrobial medicines, which improve patient outcomes and help to reduce antimicrobial resistance and healthcare-associated infections long term. These programs are highly accessible online or through in-person seminars for free, and this education can be applied at a small scale on individual farms all the way up to larger organizations. And finally, bacteriophage therapy. This is a way of destroying bacterial cells without using antimicrobials. Bacteriophages are bacterial viruses which invade bacterial cells and break them down. This research has been used since the early 80s to treat E. coli in calves, piglets, and lambs, and they experienced a severe reduction in symptoms after only 1 dose. So in conclusion, the development of new drugs and vaccines is key to combating this issue, and greater investment is required in research and innovation of new antimicrobials. Alternative approaches such as phage therapy and antivirulence drugs are being explored as potential alternatives to antibiotics. And most importantly, the One Health approach, which involves collaboration between humans, animals, and environmental professionals, is essential for addressing AMR worldwide, not just in the UK or Ireland. Thank you.
And thanks to you, Nagor. Any kind of information from SETU, please?
Yep.
The co-director of the Global Health Academy from your home country has stated that out of 6 neglected tropical diseases, 5 are documented as being drug resistant. This is a direct result of human travel, not animals. What do you have to say about that?
I talked about the example in the Netherlands where they were able to reduce their use of antimicrobials by 60%. This is purely in animal production systems, and they saw a reduction of 43% of antimicrobial resistance symptoms. I acknowledge that there are other causes for this issue, that the speed at which animal production is worsening it, we just can't be ignored.
Thank you very much for that, Nagor. And so, judges, having heard Ellen's opening remarks in opposition to the motion, intensive global animal protein production is to blame for antimicrobial resistance, and on hearing from her team, Brittany, Edward, and Alicia, it is now time for Ellen to make her closing remarks. So, Ellen, over to you, please.
Again. Chairperson, adjudicators, members of the proposition, ladies and gentlemen, I am delighted to have the opportunity to address you all once again, following this interesting and lively debate between our 2 universities. The proposition team from SRUC have made some good points in this debate. However, overall, they have failed to convince us that global intensive animal protein production is to blame for antimicrobial resistance and focus more on the consequences AMR has. The motion is key to this debate. What the proposition are suggesting is that global livestock animal protein production is solely responsible for antimicrobial resistance. Essentially, it's like they're saying that car manufacturers are responsible for road deaths without taking other factors such as weather, road conditions, and risky driver behaviour into account. And indeed, car manufacturers have put a lot of time and energy into following guidelines and regulations to make cars as safe as they can possibly be, just as farmers and the livestock sector have put a lot of time and energy into limiting the use of antimicrobials within livestock production. But, just as car manufacturers cannot be held responsible for road deaths without also looking at driver behaviour, farmers cannot be blamed for AMR without also looking at human behaviour when it comes to antibiotic usage. The SETU team have relied on proven scientific research, global experts and policymakers to offer you all here today a clear rebuttal of the proposition's argument. Brittany outlined the reality that global experts and renowned scientists are placing the blame for AMR specifically on human behaviour, in particular the misuse and overuse of antibiotics. Global experts are also placing the blame on the lack of clean water, sanitation, and poor human hygiene as the other key factors causing AMR. She also pointed out another reality. Antimicrobial resistance, unfortunately, happens naturally due to the structure and nature of bacteria. Edwards then explained the One Health approach to the issue of AMR and argued most effectively that the issue is a complex one and not as simplistic as the proposition would have you believe. He also argued that sales of antimicrobials in the livestock sector have in fact decreased, unlike the sales of antimicrobials for humans. Alicia, like all of us here today on the SETU team, is a very passionate farmer, and she found the proposition's argument to be a deeply personal attack on farmers. She outlined just some of the mitigation measures that farmers have taken on a global level to play their part in reducing AMR. This shows that each individual farm does actually matter, unlike Ligor suggested, to stop focusing on individual cases. Alicia also struck a hopeful note that this global problem is one that can be solved if everyone works together. Ladies and gentlemen, the reality is that the world needs global animal protein production to feed a growing population. This sector is extremely aware of how grave the AMR issue is. However, this sector has done more than any other to reduce antimicrobial usage, such as shown from the study that you referred to in the Netherlands, where farmers reduced antimicrobial usage by 60%. Thank you for pointing that out. Farmers have also introduced improved methods of production. They have encouraged greater biodiversity, and they continue to feed the world. To place the blame solely on us, the farmers, the custodians of the land, is not just wrong, it is deeply insulting. I strongly urge you all here today to defeat the motion. Thank you.
So thank you very much, Ellen and Team SETU. As you know, judges, the opening remarks were made by Nicola from SRUC, proposing the motion, intensive global animal protein production is to blame for antimicrobial resistance, and she was followed by her team contributions from Rowan, Kira and Nagore. So with great pleasure, I'm going to ask Nicola, who opened the debate, to now close it with her closing remarks, please.
Thank you to all of our speakers and judges for engaging with us on this critical issue. Today, our team has demonstrated that intensive animal protein production isn't just a major contributing factor to antimicrobial resistance. It is a major driver of a global health and environmental crisis, but the implications extend far beyond what has been discussed so far. The opposition. You rely a lot on first world countries that have already noticed that intensive farming has raised concerns, which is why we have these reductions in growth promoters in the first place. But you fail to focus on the other countries highly involved in this global issue. Your argument follows a personal stance on how you've experienced this issue, which is problematic, as the issue just does not occur in Ireland. It is global. A personal view is highly subjective. However, the one thing we really do agree on is that a One Health approach is needed, but globally, highlighting the interactions between not just humans, but animals and the environment. The heart of the issue isn't simply about whether antibiotics are misused. It's about an industry structure that compels their misuse, and in doing so threatens the foundations of global health. This debate isn't about theoretical risks, distant future consequences. It's happening now. It is about the endangerment of healthcare stability, the economy, where by 2050, over £3 billion could be lost on the culling of livestock alone due to this very issue. It is about the wider impact of our ecosystems, and as One Health has been reinforcing for years, the pollutants in our water systems and air that now has viable traces of resistant bacteria flowing through it. By continuing to allow intensive farming, we are not just feeding people, we are feeding AMR, and that is a threat that no individual action or policy can contain. While our opening team emphasised the link between farming practices and AMR, our closing statement must go further. We must confront the full consequences of intensive protein production, which will fall the hardest on developing countries. Due to unregulated supply chains, gross abuse, and available antibiotics over the counter, Brazil, India, China, and South Africa is projected to double the consumption of antibiotics. And we ask why? Well, it's a shift in demand, and it's caused by large-scale farms requiring the routine use of antibiotics from a study done in 2018. This is why the predictions of 200,000 newborns and 10 million deaths annually by 2050 becomes a reality and not fiction. These countries face a crisis with limited resources, compounded by the trade of antibiotic-fed livestock that could impact everyone consuming imported goods. Is it ethical or sustainable to prioritise short-term productivity over long-term global health? And further beyond public health risks, AMR is devastating our environment through waste, contaminating the soil and water. And studies have shown that only a small amount of the antibiotic is metabolised by the animal, therefore the resistant antimicrobial genes in the animal is excreted into the environment. And within these systems, livestock excretion is then used or sold as fertiliser. further applying AMR genes into arable land, which exerts pressure on the resistance of microorganisms in that very soil. This induces resistance, pollutes the environment, cascades ecology toxicity, provides food safety challenges. And did you know that arable farming takes up 80% of all land, which then goes back into intensive farms? That is a vicious cycle. So the opposition may argue that intensive farming could be necessary to meet food demands, but the data is clear from what we've said. 80% of antibiotics in the United States are used on animals and not people. Studies show extensive farms with welfare at the core reduces the need for antibiotics. Sustainable alternatives like the One Health approach can meet our food needs without compromising public health. In closing, we ask this final question. We will continue to feed an unsustainable system that prioritizes profit over global safety, or will we act to secure a future where medicine still works? Thank you.
Thank you very much, Nicola and Team SRUC. That brings our debate to a close. The judges will now be given 5 minutes to make up their scores before we will have a question and answer session. I want to confirm at this stage that we will be announcing the winner and the best speaker awards for this debate today. And we now have, as I said, a couple of minutes to let the judges do their work. So we'll recommence in about 4 minutes, if that's okay. Thank you. I want to thank both teams for an excellent performance and to thank all involved in this today, including our judges, the technical people at the background, Cynthia, of course, and Eileen Flynn, my colleague, who did an excellent job on timekeeping and tells me that there were no overruns, which is testament to how well both teams are prepared. So well done on that. Okay, guys. Well, I think we've reached the end of the road for today. A couple of important announcements to be made. So first of all, thank you to everybody who took part, and we firmly believe that in taking part in itself is certainly a well worthwhile exercise in terms of your development, and we hope that it will stand to you in the future. Thank you to all involved in making it happen, from Dawn and McDonald's in terms of the preparation, the setup, and the execution of the program. So that brings us to making the announcements. The judges have completed their work. The scores are in, and it is my great pleasure to announce that the Best Speaker Award goes to Nagor Kurtango. Well done. Congratulations. Well done. Congratulations. And the winning team of competition 1 is SETU.